Hello there and welcome back to another video. In today's video, I want to do a pretty short, sweet, and simple portable mini-NAS build because I quite enjoy storage and storage solutions, and I've been given some hardware recently that fits the bill for a project like this perfectly. In particular, Icewhale, the company behind Casa OS and the Zima Board, sent me a Zima Board 2 and some accessories for it a while back, and a mini-NAS fits the bill for these pieces of hardware perfectly. Now, for full transparency, these items were given to me for free. However, this video is not sponsored by Icewhale, and I'm completely free to say whatever I want about this hardware. They also have not paid me in any other means than the hardware that I received for free. So let's go ahead and get on with the build process, as I'm honestly pretty excited to work with this hardware because I've seen the Zima board all over the home server YouTube scene and have always thought it to be an interesting concept, especially for a small, portable mini-NAS. The first thing I did was installing this small fan that came with the Zima board onto it by taking off the bottom cover and plugging it into the motherboard. Now, as far as I'm aware, this fan isn't necessary, but it does help to move a little bit of air over the all-aluminum chassis that functions as the computer's heatsink. And yep, for those of you who aren't familiar with the Zima board, it's a whole computer in this small little single board package that's encased in this nice machined aluminum chassis. And since this is the second version of the Zima board, for specs, this thing's got an Intel N150 CPU in it, which is a 4-core, 4-thread, super low-power chip from Intel. In the home server community, the N100 and N150 chips have become very well regarded for being decently powerful for a lot of tasks, while also just barely sipping power. Plus, they also come with a decent iGPU that's not half bad at things like transcoding video. In terms of other specs, my board has 16GB of DDR5 memory and a 64GB EMMC module, but I'll talk about that a little bit more later. Now, this is my first ever interaction with the Intel N150 chip, and while I'm really not going to be doing anything too exciting software-wise in this build, as I'll just be setting up a very basic NAS, I'm sure it could handle some more interesting stuff, which I may just have to make a second video on later. I think I could have a lot of fun setting this thing up, running something like Pi-hole or AdGuard, and maybe even a VPN service as well. In any case, for a NAS, this chip should be plenty enough to feed a 2.5GB Ethernet connection, which I'll be making to the NAS through the two onboard 2.5GB Ethernet ports. I really like the choice to put two ports on here, as this opens up the possibility of using this as a network appliance of some kind, like a pfSense box, with one WAN and one LAN port. Plus, if my network infrastructure was up to the task, I could also theoretically create a link aggregation between these two ports and have 5GB connection to my NAS, but I won't be doing that today. Now, let's talk drives for this mini-NAS, because I've only got 2 SATA ports on the Zima board to work with, so it's ideal if my drives can be of decent capacity. Conveniently, a while ago I came into possession of 2 8TB Seagate Skyhawk AI surveillance hard drives. And of course, while I'd usually opt for a NAS grade hard drive, and at least for me personally, a Western Digital or HGST brand drive instead of Seagate, I can't be exactly picky in this market, and so these are what we'll be using today. And while I could just stop at these 2 hard drives and have a very competent NAS that could be configured to have either 8TB of redundant storage or 16TB of non-redundant storage, I won't be stopping here, as I'm going to want more performance than an array with just 2 drives can get me. So I'll also be throwing in these 2 256GB Western Digital SN730 SSDs that I have on hand for refurbishing desktop computers. I'll be adding these to the system with this dual NVMe to PCIe by 4 card that Icewhale sent over along with the Zima board, and I can plug this card into the Zima Board 2's inbuilt PCI Express slot. To assemble all these parts and keep it at least somewhat coherent, I also have this Zima board dual 3.5-inch drive cage thing that should allow me to mount everything together and make one cohesive package with it. So let's begin. And the first part of this process involves taking the screws out of the bottom of the Zima board again and replacing them with some longer ones that came with the drive cage. Then, these new screws allow you to mount the board to the chassis with the same screw holes that the old screws on the Zima board used. I will say this mounting mechanism is a little bit cumbersome to work with, but it's not the worst that I've dealt with, and I do like how efficient they are being with the screws and the mounting holes. After the board was attached to the drive cage, I started to work with the little bracket and PCI Express riser that will allow me to plug in the NVMe SSD card and mount it to the assembly securely. I will say, this part of the assembly did require some thought to figure out exactly where they wanted all of the different pieces of hardware to go, and the lack of an instruction manual in the box was definitely felt. It wasn't that bad overall, and I think most people building something like this shouldn't have any issues, but for a more average consumer, instructions to clear up any possible confusion would be nice. So now, in order to mount the PCI Express card bracket to the side of the drive cage, I need to throw the two hard drives in, as the PCIe bracket mounts to the cage using the same screws that hold the hard drives in. So let's toss those two 8TB Seagates into the assembly. Then I can screw them in using the provided thumb screws, and I think the fact that they're thumb screws is a nice touch, and now I can plug in the NVMe card and secure it to the bracket with an M3 screw that I did have to source myself, because the hole in the bracket isn't threaded, and so the provided screws that I assume are for this purpose just don't work. But just like that, with a couple of cables plugged in and the NVMe SSDs installed, this thing is done. And I have to be honest, I really do quite like the way that this all goes together. It really is very sturdy, and the machined aluminum plus black accents reminds me a lot of how the NVIDIA 20 series Founders cards looked. And I have to be honest, those are some of my favorite looking graphics cards to ever exist aesthetically, and so I really do like the way the Zima Board 2 looks when it's assembled like this. But with all of that out of the way, let's plug this thing into power, a keyboard and mouse, and a monitor, and boot it up into the pre-installed Zima OS, which is located on my Zima Board's 64GB onboard EMMC storage. Zima OS is a fork of the very popular Casa OS operating system, and it's been simplified and really tailored towards being used as a NAS. From what I could gather poking around in it as well, it looks like it also should allow you to run auxiliary processes on your NAS very easily. And a lot of these are processes that make sense to be running on your storage server. I see several different database applications in here alongside Image, Plex, Jellyfin, and a bunch more. Now, I'm not going to be messing with this feature very much today because frankly, I've got plans with this setup for this NAS that are slightly outside of the capabilities of Zima OS, but I did poke around a tad bit first in the web interface from a separate computer. In particular, I created two RAID 1 storage pools, one with my two 8TB hard drives and one with my two 256GB SSDs. From there, I was easily able to browse the files and folders on these drives, and I created two shared folders with literally just a few clicks, which I genuinely think is awesome. I was able to connect to these folders, and just like that, I had a functional NAS, and I could write to both my hard drive and SSD storage pools. The hard drive pool was pretty quick, though not quite able to fully saturate the 2.5GB link between my desktop and the NAS, which is likely due to the speed of the hard drives. As for the SSD storage pool, unsurprisingly, it saturated the link just fine, and it would probably even saturate a 10GB link as well if I had a way of adding one onto this system, which the fact that there's no more PCIe slots now that I've added an SSD is probably one of its biggest downsides. I would really like to be able to have NVMe SSDs and a 10GB networking card. But for today, that's all that I'm going to be doing with Zima OS. I think it looks really awesome, and I really do want to explore running different applications on it, especially because it seems to have support for a lot of things, but right now, I'm going to set up my storage pools differently, and I'm going to need a different OS for that. In particular, I would like to set them up so that the two SSDs can be mirrored and ran as a cache for the mirrored hard drive pool. And from my surface level research, it doesn't seem that Zima OS is gonna make doing that very easy. But what will make it relatively easy is TrueNAS. So let's get that installed on here. After creating a TrueNAS installation USB, I started the installation, but kept running into an error regarding EMMC BLK0 and finding partition 2 on it. This was indicative of the installer having some trouble when it came to formatting and working with the onboard EMMC storage, as that's where I wanted to install the OS to, because if I did that, it would allow all 4 of my other drives to be completely free for use in storage pools. I tried a couple of things to fix this, such as completely wiping the EMMC, but what ended up working in the end was this command that I found online, which, as far as I understand, basically modifies the installer program and tells it to try more times when messing with the EMMC before giving up and erroring out. After executing this command and reattempting the installation, everything went flawlessly. So after the installation was done, I pulled up the TrueNAS web interface on another computer and began configuring my pools, this time with the SSDs dedicated as cache. One thing that I found really convenient here was that all of the hardware components on the Zima Board 2 were completely recognized in TrueNAS out of the box, and there was basically zero weirdness with using a third-party operating system. Obviously, that might not go for everything you could install on a board like this, but I can't lie, I do appreciate it making my life easier, at least in this case. Moving on though, with my pool created, I could test the performance, which I expected to be pretty decent considering that I have NVMe SSDs for cache on the hard drive array, and I've also got 16GB of DDR5 memory in this thing, which should help with ZFS caching. Now I should note, because I want to provide some useful information on this product, Icewhale sent me the 1664 model of the Zima Board 2, and that model number indicates that I have 16GB of RAM and 64GB of storage. They also seem to make an 832 model, which has 8GB of RAM and 32GB of storage, and I can imagine that that might be good for some simpler deployments. However, the 1664 model is almost certain to be more versatile if you're planning to run more programs simultaneously. But moving on, with this new array, I was able to get slightly better performance than before, but strangely, it still didn't saturate the 2.5 gigabit per second connection when writing to the array. I could tell from the drive usage indication lights that it was writing to the SSDs, so if you do know what's going on here, please give me some details in the comments below, especially as I'm going to be redoing my main NAS soon, and I'll be moving to TrueNAS during that process. So I could seriously benefit from any meaningful TrueNAS tips if you have them. As for reading from the array though, I was pegging out the 2.5 gigabit connection the whole way as I expected, and this was genuinely great to see. And for this performance metric, I am definitely confident that it was due to the NVMe cache. But alright, that's actually all I've got in terms of the build today, especially because my goal was really just to do a small, fun project for the sake of making an interesting video, and also fulfilling my promise to Icewhale that I would showcase their product in a video. And on that note, thank you again to Icewhale for sending over the Zima board and the accessories in this video, because I think it is a genuinely cool product and I'm grateful to have been given the chance to mess with it. Again, Icewhale hasn't paid me for this video with anything other than the hardware that they sent over, and I'm honestly free to dog on it or to praise it if I want. And I will say that I think that while limited in some departments, this is honestly a really sweet piece of kit for a home labber to have. So if you're interested in the Zima Board 2, I do have a coupon code for you in the video description that you can use when purchasing one. I don't get a kickback from the link in the description or the coupon code if you choose to use them, so feel free to do whatever you want to with that. Well, that's all that I have for you in today's video. I hope that you were able to at least enjoy it and maybe even learn a thing or two. In any case, I hope to see you next time. Goodbye.